My name is Hector. I'm an iOS developer at Spotify. And during the last year, I've been working a lot in the homepage of Spotify and also in user onboarding. So nowadays, my team is doing lots of A/B testing to figure out what the users like and what they don't like. And we're having lots of learnings about this through this technique. And I'm going to share with you some things that we have learned along the way. Spotify is not available in Belarus, so just wanted to give a few numbers of who we are. We have around 100 million users. 40 million of them are paid subscribers. We have about a catalog of over 30 million songs, and we're available in 60 markets. So not in Belarus, but there's always a VPN for that. In the iOS project, is kind of a big project, big scale, about 50 developers every month contributing to the code base. It's roughly 0.7 million lines of code, and keeps growing a lot. And concurrently, we're running more than 100 A/B tests at the same time, so it's lots of tests running on in this product. And this is a talk that I prepared with a data scientist, a friend of mine, Buxton, and hope you like it. Check it out. So first is, what is A/B testing? And maybe you've seen sometimes your Spotify or any other product, how your version looks a little bit different than somebody else, like your friends. Maybe it's the color of some button, maybe it's the size of some user interface element, or the order of them, small tweaks like this. And if you haven't seen it on Spotify, maybe you've seen it on other products like Facebook. They do lots of A/B testing. And this is one that caught my attention a lot. They had two different groups where they were testing emojis. So for one group, they had the standard emojis that comes from the operating system. And in another version, another test group, they had these custom-made emojis. And I love this one, because it looks like, I forgot something very important, like paying his taxes or something. And yeah, well, so you've all been part of an A/B test at some point. And what sometimes some people tell me is that they think this is a bug, because you see the same app version presenting different information or in a different way. But the truth is that it's not a bug. Most likely what is happening is that you are part of an experiment. And the technique that we are using to carry on these experiments is called A/B testing. Basically, we present two different versions of one product, of one view, and we measure how these different versions perform. And it's nothing new. It's been used a lot of time before in clinical trials to figure out how effective some treatments are. In healthcare, it's called split testing. And before mobile, it has been used a lot in web development. So if you've done web at some point, you probably have done A/B testing. And I want to catch your attention with what's the value of A/B testing, or why would you be interested on using it? And I want you to think about one of our products that we have integrated with, and that is very popular. It's Tinder. So we integrated Spotify and Tinder, and recently I was helping a friend set up her Tinder. And I got this question, like, what changes do you make to it to make it the most effective version? So that you maximize the number of matches that you get. And you can start by just making your project, making your profile. You got a nice picture, you got your information, and then you're like, how can I improve this? And you read a piece of wisdom, like in Men's Health or Cosmo, that says, if you wear sunglasses or if you wear an accessory, then you get more matches. So you follow this piece of wisdom, and you change your profile with these nice sunglasses. And then you measure that. You measure that effect. And it turns out that now you have 5% more matches than before. So so far it looks like it's working. It looks like this version is better. But maybe what you are missing is that just this is what could have happened. So you introduce the sunglasses, you observe a 5% increase in your matches, but what could have happened is that actually your original version will have performed better. And this increase that you saw is not because of a change you introduced, but it's just seasonality. Like, for example, users swipe more in winter, and you didn't account for that, and you were not aware of that. And there is no way to tell what is the exact effect of this change unless you do A/B testing. And now imagine this is not your share of matches, but something more important, like, I don't know, let's see, the share of premium conversion, like revenue that you're losing, or I don't know, user retention, or whatever metric is the most scary for your product. And that's one of the reasons why we're using A/B testing. And I want to tell you how A/B testing works a little bit at Spotify. So we have, because of the degree of integration that we need with all our systems, all our pipelines, everything, analytics, we have to use our own custom framework, and it's called ABBA, like the Swedish pop band. And for ABBA, everything starts with your username. So everybody has a username, and what we do is that we hash that username, and this hash has, just like any other hash, it has a uniform distribution, which means that there is roughly the same chance that your username ends in one bucket or another. And then by selecting these different buckets, this is just an example here, but we have like thousands of them, so we have lots of resolution. By selecting some of these buckets, we can roll out some features to a randomized percentage of our user base. And we use the same mechanism also to roll them back in case something goes wrong. So we use it both to carry A/B tests and also to make deployments and limit the scope of damage if some features don't perform as we expected, or if they introduce some bug that we were not aware of. And with a little bit more of logic, we can target actually specific markets or specific demographics or specific user attributes like registration dates or things more specific. And this system also comprehends a very simple dashboard where we set up the tests, and also very importantly, where we can see the results of these tests. That's also very important. And that's basically the cloud side of our A/B testing framework. From the client side, it's actually much more simple. You have the device, and right after the login right after the session starts, we try to load the cache values of these flags of the A/B tests. Or if we don't have any cache, we just load the default values. And if there is a connection, yeah, we try to resolve those A/B flags, get them back to the device, and cache them. This is an asynchronous step, so they're not sometimes always available after login. But if it's a test where it's very, very important that we have those values right at login, we can put those flags into the login payload. And how does these A/B flags look? They look pretty much like this. It's just a simple dictionary where the keys are the name of the test, and each test group receives a different value. So this is what happens, actually. Let's see. I have this code here where, let's see, if I have the flag pink buttons and the value in that flag is 1, then I execute the alternate path here. So this means that every time that we ship something, we're shipping both the control version and all the variations at the same time. And all the variations are there in the application, and we can turn them on and off from the backend. So an actual experiment will look like this. The variation has one value, the control has a flag, like the default state. Here's 0, here's 1. And they produce a different effect in the client. This is a change of the shuffle play button, and that's how the user will experience this change. Then, well, we log all the impressions and interactions, everything, like when you scroll horizontally, vertically, when you click everything, when you open a page, everything we keep track of it, and we feed it into our analytics, and then we can analyze them in many different ways, through dashboards, through Kibana, and nowadays we use a lot of BigQuery from Google. It's an amazing tool, and yeah, and that's how we carry on our analysis. And as you can see, there are lots of moving parts, lots of work to maintain, and this involves lots of people and infrastructure. So you might think that maybe A/B testing is just for really, really big scale companies. But good news is that nowadays this technique is so popular that there are lots of third-party actors out there that have really good SDKs and really good products targeted for A/B testing. And you don't need to make such a huge effort just to try it out. So these are some of the actors, just a personal preference. You'll have to check them out, like which one suits the pricing better for your product or the SDK that you most like. So that's basically what is A/B testing, but how do we carry it on at Spotify? Well, I have a framework of 4 steps on how to run it. The 4 steps are very simple. You start with a hypothesis, then you design the test, you run the test, and you analyze the results. And then based on those results or the results of those analyses, you can create new hypotheses and repeat the cycle again and again and apply those learnings into your product. So I'm going to give you an overview quickly of this framework. So the hypothesis is where everything starts. This is an idea that you have, like something that you believe. This comes from company goals, this comes from user research, historical insights, maybe research, sometimes intuition even. And this could be like, if we make the button bigger, if our buttons are bigger or if our images are bigger, users are going to tap more in them, things like this. Then, based on your hypothesis, you need to figure out how do you test if it's wrong or not. And this is part of the second step, which is designing the test. So the first important thing of designing your test is that you have something called target metrics. These are metrics that you're going to measure both in the control group and both in the variations of your experiment. And you're going to compare those two values, see which one performs better. I have a very simple example here, continuing with the pink button. A target metric is something that you can measure that is directly related to the behavioral change that you're introducing. So if I change this color, this color here, maybe what I'm looking for is that they tap more this shuffle play button. So the most immediate metric that I'm looking for is the average number of shuffle plays per screen. And something to keep in mind also is that every experiment, you're changing behavior of the user. And you need to measure the most immediate metric to this behavioral change. Back in my social Chihuahua example, there are many metrics that you could have gone for, like number of matches, maybe number of replies that you get, maybe number of walks in the park that you have with other users. And every time that you jump into another metric, this is very important, you are introducing assumptions and you're reducing confidence in these metrics. So my most immediate metric, the most immediate behavior that I'm changing here with the sunglasses is that the other users are going to like the glasses or are going to like my picture better, and they're going to match me more. I could have selected something different, like the number of replies, but then this metric is not so direct as the number of matches. This depends on other factors, like what do I say? Maybe my text messages are really good, maybe they're really bad, but they don't correlate directly with or most immediately with the glasses. So keep that in mind. You introduce behavioral change, measure that change. Now, how big should the test group be? This is a big question. So you go for a large test group, you go for a small one. Well, each one has different advantages and they behave differently. So if you go for a large test group, this is what you've got. You have less space to run tests at the same time, but with bigger test groups, you have more confidence in your results. You can trust them more, because if lots of users are behaving in some way, then you're more certain that this is not just a statistical noise in your metrics. And also, this is very important, if you have a very large test group, you have a larger impact on business. So if you're doing something risky, I don't know, like changing your homepage or a change that you think is risky, well, maybe if there is lots of risk, maybe you shouldn't go for a large test group because you have a large impact in business. If you go for a small test group, then you have more space to carry on different tests at the same time. You have less confidence in the results, and you have a smaller effect in business. And I'm going to show you like how we are applying this in some use cases. But now the question is, like on a very high level, what's the effect of big and large test groups? But how big, what's the exact number that you're looking for your tests? And this is called a power calculation. And I'm really bad at math, but I'm going to show you how does it behave and how can you do these calculations yourself. So, yeah. So I'm just going to run a calculation really, really quickly so that you get an intuition of it. Where is it? Here we go. You can just Google power calculation, and you'll find like lots of calculators for this. But what I want you to take from this is to realize this. So basically, there are two important metrics that you need. One is what is your baseline conversion. So this means if you have a big button in your product that says buy, and let's say 1 of 10 users that visit this page click this button, then your conversion rate is 10%. 1 of each 10 of users clicks buy. Okay, so that's your baseline conversion. And then you need to anticipate a little bit, like what's the effect of your test. So let's say that I'm just gonna think about something like put this big button a little bit bigger, or make it a little bit more prominent, or I don't know. And it's a small change, so I anticipate like it's gonna be around a 1% increase of the 10% that I have. And you can see how this sample size is pretty huge. It's like 1.5 million. Maybe you don't have that many users in your application, so what I suggest that you do instead is that you go for more radical changes. So think about something that could create a big impact, and then you can measure, let's say, maybe with a big change, you can actually increase numbers like pretty radically. Let's say instead of 10%, maybe now you can think of a conversion of 15%. Oh, where is it? Well, yeah. And you can see how the sample size is related to the inversely related to the effect of the change. So a small change, let's say if we want to measure a really, really small change, 5% increase, we have almost a sample size of 5 million. If we make a very radical test, where we shift metrics 10, 15%, this sample size is much, much, much smaller. And that's basically That's basically how you do the sample size very easily. This is a very simple example, but power calculation is the term that you're looking for. Let's go back here. So now, what about the duration of the test? How long should they run? And this is also important. Here we go. So they should be as short as possible to give you an answer, and long enough to account for seasonality. Seasonality are all these external factors that affect the usage of your product outside of your product, like the season. Or one effect of seasonality that we have a lot in Spotify is that the music habits are very different between weekdays and between weekends. So all of our experiments, they should run 1 week at least. So that, because if we check our numbers on Friday or on Saturday, then yeah, it's gonna look maybe like they listen more, but it's not because of this experiment, it's just because of seasonality. And depending on your product, seasonality time is different. Like for us, it's 1 week, but I've seen other products like e-commerce products. They are very sensitive to paydays. So depending on the country, like some countries have paydays every 2 weeks, some every month. So you'll have to account for that. And now that you design the test, you run it. And what's important here? Well, the first thing is that you should watch out for conflicting tests running at the same time. So every cell, here I have all these 10 cells, and it's important that you don't run different tests with the same users, because then when you get your results, you're not sure what of these tests actually influence your metrics. So watch out for collisions between the test groups. And then another mistake that I've seen very often is cutting the test too short. And this is like a football match. Let me explain. So the standard match duration is 20 minutes plus extra time. This is a sample size of a football match. If you take a much smaller sample size, like 20 minutes, you don't have enough information to determine which team is better. Like, it's an inconclusive test. And then if you go for a lot more than 95 minutes, this is unnecessary. Like, within the first 25 minutes, in most of the cases, you will realize which team performs better than the other. There are exceptions, of course, but it's always, mostly it's going to behave like this. And an example that I like from this year in the Champions League. So you had Copenhagen versus Barcelona, and on the minute 48, you got a goal from Bruno Cesar from Copenhagen. And then you could have things like, Barcelona lost already. But right at the very end, you got a goal from Ronaldo, and then you got a goal from this Morata person for a final score of 2-1. And some tests behave like this. So when you see the data, maybe they start like, maybe we were wrong. And in the end, you see the result that you were expecting for. So don't cut them short. That's a mistake I've seen often. And then once your test has run, it finishes, then it's time to analyze those metrics. You start, as I said, with the most immediate metrics, and then you progress to higher metrics and deep dive if you need to. All right? And then with that knowledge, then you use it to formulate new hypotheses and repeat the cycle again. So I have a few case studies where all these steps of the framework I think are more clear, and let me guide you through them. So my first test case study, I call it losing calories, and it's about burgers. So everybody loves a good burger, except of course if you're trying to lose weight, then it's just frustrating. Or if you're trying to navigate an app with a hamburger menu, then it's even more frustrating. And at Spotify, actually, we were doing that mistake. Like our main navigation system was using a tab bar hamburger menu. And the problem with the hamburger menu is that, first of all, it's very, very small. So it's difficult to see. Then the icon, like, it really doesn't convey any of its meaning. You all understand it because you're used to the human user interface, the user interface of mobile. But for lots of our users, it's actually not very clear. And then on top of this, you need an extra click just to see what's behind it. So the problem with our application was that the value proposition, what the product offers, was not clear for lots of users. So the search, browse, radio, and your music, they never find it out. So somebody thought, what about a better navigation system? What about tab bar navigation? How will that perform? And this is where we go to our first hypothesis. Check it out. So this is step 1 of the framework that I mentioned you. And this is how this hypothesis looks like. So by switching to tab bar navigation, we expect an increase in the share of users who click at least one menu item. So we expect, basically what this says is that we expect users to click more in the tab bar navigation menu. So they see the icons, they explore them more than the hamburger menu. Then the step 2.1 of this framework is that you have a target metric. Our target metric is right here in the hypothesis, the share of users who click at least one menu item. And then how long do we run this test? The duration of the test. This is actually, sorry, before that. Our test groups, how do we select this? Changing the navigation of an application is a radical change. And lots of these changes can go wrong. Lots of times the hypotheses are not what you expected. So this is a risky test, let's say. So we run a 1% of our existing user base. As I said before, a small group is conservative, and you have less impact in business. So we go for 1% of existing users. We want to make sure that they are not alienated in this change. And then for new users, we can be less conservative. We can ramp it up to 10%. They don't know the previous navigation system, so there is no risk of alienating these users. How long do we run this test? As all of our tests, we run them for a 1-week period to account for these different music habits for the week. And these are the results that we got. So, well, we were right. People in general click more menu items, explore more the application with the tab bar navigation, as much as 30% more in average. So they see the icons, they're interested on exploring them, like the value proposition is more clear, and they click them. And then we also observed something interesting. Overall, the users are navigating more into the app, and they're clicking more things, as much as 9% more, or in average 9% more. That's a huge increase in usage. And if you've been part of the debate of tab bar navigation and hamburger menu, you could think that this is kind of obvious. Like, the hamburger menu is probably not the best way to navigate an app. So if we knew this already, why would we A/B test this that is obvious? Well, the answer is that then we're able to measure the effect of specific changes. So we can tell now that navigation can impact the product in a huge way, like as much as almost 10% of extra clicks. Now for a less obvious A/B test, this case study, I call it home in Mexico. I'm originally from Mexico. And this is what happened. So music is something extremely personal. Your perception of music and how you enjoy it and what you like is different, like from person to person. And even genres that are very well defined and that are very well mapped and specified, like rock, they're even different for people between each other. So maybe for me, when I think about rock, I think about Nick Cave or In Excess. And for somebody else, when I mention rock, maybe they think about White Stripes or Kings of Leon. So it makes sense that the application that you listen music for is personalized for you. But our homepage was actually the same homepage for everybody, no matter what music do you listen to. Everybody got the same homepage. So one of the changes that we thought was to make a very personal experience, just like music, a very personal homepage that will be different for everybody, and that it will be based on what you listen to, your radio stations, what you have played recently, all these signals of what is the music that you're more interested on. And we come to our hypothesis. So we will measure an increased second week retention by using the new home as a start page. So we're going to try this new homepage that is very personal versus the standard homepage that we had before. This is our hypothesis, and our success metric is right here. Let's see. Yeah, that's increased second week retention of our users. And we go in a very similar way to our previous test. So it's a very bold experiment. Changing the homepage, changing the start page of a product, it's a big change. It's risky. So again, we go with 1% of user base of existing users and 10% of new users. It's the same logic. So maybe previous users, in general, users are very reluctant to change. Every time that we change something, they don't like it. And you might have seen these examples, like when Instagram changed the color of the icon. When we change the color of the icon, users are extremely receptive to change, and they don't like it. So we want to make sure that these existing users, we want to make sure how do they react to this change. And again, new users, we don't need to be that conservative, so we go for 10%. Again, 1 week. And this is what we've got. We run this test in 5 different markets. US, UK, Germany, Austria, and the users like it. We were very happy about that, but one market in a specific, like, it didn't work as we expected. It was Mexico, actually. So these are very tricky tests, because when you run this kind of test, you're expecting answers, and instead of answers, you got more questions. So these are the questions, like, why in Mexico didn't perform as we expected? So these are just like the most immediate questions that you come up with, like, is the localization good? Are the recommendations relevant for the market? Are there technical restrictions that we're not aware of? So this happened during this year, and I remember that in January I was back in Mexico, and something that I noticed was that mobile network is really slow, like incredibly slow. Lots of latency, speed is really low. So we start there, like maybe it's the speed of the networks. Now the payload of the new homepage is bigger, so maybe it takes more time to load, and maybe that's why users don't like it. In general, they're very receptive to how fast the app loads. We dive deeper into the metrics, so we collected the speeds for all of these markets. And you can see, well, all these 4 markets, they have very high internet speeds in mobile, and Mexico has almost like half of it at 7.4 megabits per second. But also, coverage of 4G is not that good in Mexico. So usually you will have 3G, which is 3.7 megabits. Pretty slow. So from this test of the new homepage, we go back to creating a new hypothesis, just like I told you about this framework. We use the results to formulate a new hypothesis. And in this case, we thought about that. Maybe the network is too slow. Let's do something about it. So by compressing the data sent for home, more users will play on day 1, 2, and be active during their second week. So we're zipping the JSON payload. Now it's smaller, we send it, and we try again. So we got the results, and it turns out that it was not that, the test was not, it was inconclusive, that was not the reason why they didn't like it. And we keep asking these questions, doing hypotheses and running them. And then in the end, we figure out that it's a market that consumes its own music. So if you check out the charts of different countries, most of them, they share lots of artists. But for Mexico, they really like their internal music. So their charts are very localized. And that's what we learned. So now when we send recommendations like a hip-hop playlist, well, it needs to be hip-hop with lots of entries from Mexico. When we send the hits playlist, well, it should be localized to Mexico, mostly Mexican hits. Oh, well, we learned that. We applied it into the product, and now it's performing as we expected. And then the pitfalls, what are the most common mistakes I've seen in A/B testing? One that is very frustrating is something that I call analysis paralysis. So you get all these insights, you get all these learnings, and you stop there. That's not the idea. The idea is to learn from your users, learn about your product, and then change the product based on these learnings. It's not just about learning, but applying these learnings. Then a second mistake that I see is that you hear about A/B testing, and you start formulating hypotheses and designing experiments. You run them, and then when you try to check out the data, there is no data because maybe a pipeline is broken, maybe in one refactoring the logging was gone from the client. And this has happened to us a few times. So now what we do is that we include logging into the regression testing, and we include logging into unit tests and all the levels of testing that we use. Another error I've seen is too many small changes. So you start with the glasses, for example, and then you add something else, and you change one of the titles, and you get carried on with too many changes. And then when you get the results, you are not sure what was actually the reason for your new metrics. Was it this new title? Was it this change here? Was it this one? So stay to a very concise change. And finally, my favorite error is that you get the results and they contradict what you believe, and you just ignore it. Well, I ignore the data and I just go for what I believe, and that's pretty bad. Yeah. So don't listen to your heart, listen to the data instead. And finally, just to wrap up of this introduction, is that I used to think about A/B testing like a shipping tool, and that by making lots of these experiments, eventually we will hit the prince frog. If you've heard about these stories, like a prince that is a frog, and there is a princess or something that needs to kiss all these frogs, and eventually hits a jackpot. And I thought that A/B testing was something like that. You ship a lot of stuff, and eventually you hit the prince. But no, it's not true. Not exactly. So what I learned is that A/B testing is a learning tool with a scientific basis, where you compare your ideas against the reality and find out if what you think is true or not. And then you use those learnings to apply them into the product and improve it. And then knowledge is your return of investment for every test that you run. So as an investment, every test costs money, time, effort. So you need to design your test, like which ones you're going to run first or last, depending on this. Maximize learning. Then we fail lots of times with this hypothesis. Lots of the things that we have believed, they were wrong. And this might happen to you when you start running your A/B tests. Unless you have an exceptional intuition, you're going to fail most of the times, and that's fine. That's totally fine. We're mistaken also very often. We fail a lot as well. But the important thing is that you learn from that, and you incorporate those learnings into the product. And finally, my call to action is that you try A/B testing. It's one of many tools that there are. This is quantitative testing, one tool more in your belt. And it's a very broad topic, and it's very difficult to cover it in 40 minutes. So I have 2 resources that I want to share. This one on your right is a book by one of the founders or co-founders from Optimizely. And they review lots of use cases, some of them really, really interesting. Lots of them about the campaign of Obama during 2008 and how they use A/B testing to optimize this. And this one on your left is a set of videos from O'Reilly with a little bit of the math and science behind A/B testing. Both great resources. Check them out if you want to know more about them. Now the questions. If we don't have time to answer your question right now, I'm going to be around, so yeah.